Right, so I think it's time that we get going with the second part of our AI, Big Data and Democracy event. So AI, Big Data and Democracy event is part of the Alan Turing's Artificial Intelligence Fringe festival that runs throughout March. And in the first part, we saw some talks that they try to set up a theoretical grounding on AI and democracy. In this part, we will follow a more pragmatic approach, and we're going to have a series of tools that they try to address this great challenge of AI and democracy. As a reminder, this event is recorded, but only the presenters will be recorded. All other attendees will be headed out, will be anonymized. You can, however, and you're please do so, participate either by the Q&A function of Teams application, which is located between the chat and the people button on the top navigation bar of Teams. And we also run in parallel a Mentimeter survey, which you can see if you follow this QR code, or if you just go to menti.com and use the code 6906838. We will give you some time after the finish of the 5 tools to fill out this survey. So from now, it's okay, don't worry about it. But please post your questions to the speakers through the Q&A. So it so happens that the first speaker is me, and I will be presenting BCause. So I am Lucas Anastasiou. I am a researcher in the Open University, the Knowledge Media Institute, part of the Intelligent Deliberation idea group. And I'm going to present you BCause, which is a tool that has a structure and decentralized discussion system for decision making. So our world out there has a lot of debates, a lot of topics for discussion, which is either about policymaking, about the future of the NHS, about climate change, about knife crime, which is a recent topic here in the UK. There is also a lot of philosophical dilemmas, ethical dilemmas that we need to discuss, like is AI an existential threat to humanity, about free speech, about abortion laws. We also have regulation topics to be discussed, like net neutrality, gun control, financial regulations, and many, many others. So the world is no short, no poor of topics to be discussed, and topics that actually have a great impact into our everyday lives. So the way that we do that is that we usually have, the way that we do that in an online environment is that we usually have platforms like forums or social media that they try to follow the linear dialogic approach that we have in our everyday conversation flow. But there is also some other platforms that they try to introduce some argumentative structure into this discussion. So we see things like threads or sub-threads. We see things like trying to organize the arguments into multi-levels or into a hierarchy. We see platforms that they try to organize it into pro and cons. And we have the much more dedicated argumentative solutions that each piece of what you say, it belongs into an argumentative ontology. It has a function. It can be a very fine-grained nuance. It can be attacking, it can be supporting, it can be pathetic, it can be many things. And it's highly expressive, but at the same time, highly complex. So if in this very simplistic chart of the popularity of these solutions, you will of course see that the social media solution, these solutions that have this linear way of emulating discussion online, are way, way more popular. There is a very clear skew towards the left, to the pure linear. And there is very good reasons why the dedicated argumentation tools have not taken off over the year, and that's because they have a very high cost of how people will engage into these platforms. So in our tool, the way that our initial aim, our central development idea is that can we actually balance these two words, the words of purely linear discussion and the words of argumentation discussion? And we did that by keeping the elements that make social media so engaging and so familiar and intuitive to the users, and adding a very light level of argumentation into that. And of course, also adding some AI goodies that I'm going to show in a moment. So argumentative discussion is based, as I think as Anna said before in the part one, in IBIS model, which is issue-based information system. So you have your issue, your topic that you're discussing, and people are posting their positions, their ideas or solutions, if you like. And each one of these positions has its pro or con arguments, either arguments that support or arguments that oppose this position. And we also retain the chronological order of how these happen. We also have a very explicit view, a render, a visualization of how these positions of the users are structured into this argument tree. So you will be able to very quickly see which position has received, for instance, the most con arguments. And we believe, and of course, you will be able as well to reply directly to a user. So we believe that we have struck the sweet spot between these two words. And of course, we have some other things. We allow the user, we have some things to help user to reflect on a given position. So just before entering into a position, we ask him to post his agreement to a given position before posting an argument. And also he's encouraged to say how much polarized this position will be, how much trustworthy, whether it should be prioritized, and whether people will agree into that to make a prediction of that. And after you have posted that, you will be able to compare your opinion of these dimensions according to the mean of the community. Now we have also incorporated some artificial intelligence into our platform. So we have on the left side, as you will enter the platform, a summary, an automated report of what is going on, which is very useful for people that they're just joining the conversation to offer a quick glance of what's going on, but also useful for people that they're returning after a few days or weeks and they want to see how the discussion has evolved. This will give them a quick overview to take them up to track of what is going on. We have also implemented some soft nuggets, what we call sense-making nuggets. So we have an underlying algorithm that is able to automatically detect what are the points of interest of this discussion. So we're able to algorithmically detect which one is the most contested position, which one is the most opposed position, and a position or argument that needs attention. It hasn't received yet much engagement, interaction, so we think that you should point your focus into that. And to promote evidence-based reasoning, we have also implemented a recommender system that, given a certain position, it goes out and fetches external scientific evidence that it will be able to support this given position. So we query the scientific literature, we fetch papers, and we actually show a short summary of that paper that if you believe that is relevant to your position, you will be able to attach so that you make your position stronger. Your argument is based on evidence, on hard facts. And we have tried out extensive experiments with this platform, and we have actually some very encouraging findings. So first of all, the structured discussion around arguments using this simple EB style, contrary to what you will expect that it will diminish the participation, the engagement, we actually found that it actually promotes it, and it actually leads to a better, more healthier engagement of people. It actually has a positive effect in mutual understanding and the sense making. So mutual understanding of the community, of the group that is discussing this topic, but also the individual, the way that an individual makes sense of the overall topic. The discussion itself is much more coherent, and it spans around more diverse topics, which is also a very good thing to have. And lastly, but not least, we have observed reduction in polarization. So what you see usually in social media is that people are entrenched. They create their own subgroup and they take very partisan views on a topic. This creation of these subgroups, we have observed that is much less using this way of discussing. So now I'm gonna share my screen to show you the tool in action. I hope you all can see my screen, and I am in BCause screen. I enter a debate that is about whether we should reduce hate speech. How can we reduce hate speech from the comment section of newspaper? So if I go on the left side, I will see a quick summary that it will quickly give me an overview of what's going on. So I can see that there is two main arguments. Those that believe that should be banned to create more inclusive and tolerant environment, but there is the others, of course, that they say hate speech in the very end is free speech and we should just keep it. Some hints of what is the most opposed position and what position needs attention. If I go into a given position, let's say to this position of Fabio, I will be able to give my opinion or add another supporting argument or another opposing argument. I will be able to reflect. I have already reflected on that. But let's say I say, oh, this will be a very much polarized position. It shouldn't be trusted. It shouldn't be prioritized. And I don't think that people will agree with that. And then I can see how much my opinion differs to the group average. And of course, I can go and fetch some external evidence. So given this position by Fabio G that common space enhances social participation and should not be completely eliminated, nevertheless, it should be regulated. So he has the position that, yes, but we should regulate it. I can find some relevant papers from the scientific literature. So let's see. It's talk about the deliberative debate, and I can see a summary of the main argument of this paper. And if I like it, I can attach it as evidence into the position, and I can see also other positions regarding this. Last not least, I would like to show you the analytics that we have in place for BCause. So here I will be able to explore what each person has contributed and see his positions around this issue, or if I want to see on a specific, on the second chart, I will be able to see what positions has received positive, favorable agreement from the user, and who has done this, and what are the main arguments that they have used for their when they express their opinions. And yeah, I will now stop sharing my screen, and while I try to upload the next presenter, let me introduce you to the next presenter, which is Professor Anna again, and she's going to tell us about DemocraticReflection, which is a platform that is used to harness, to collect opinions of people while they are watching a live debate. So imagine that, yeah, I will let Anna to do the talking. Anna, I think you should be able to have control on the slides. Thank you, Lucas.
Do you want to get any questions, or people can ask questions at the end?
We will have a dedicated section at the end for a collective answering all questions on all the tools.
Okay, thank you. I'm taking control. Okay, so this is a completely different technology that I want to describe and demonstrate, and that sets ourselves in a completely different scenario. So one, of course, deliberation of public issues does not happen only online. And in particular, if you think about deliberative democracy, one of the most important democratic moments for democratic society is during general political election. So democratic reflection has been designed as technologies that really could enable new way of citizen engagement with the live political debate during an election campaign. And then I'm not gonna describe this now, but it's also been expanded to also being applied to the engagement with video testimonial through its feature of audience feedback interaction. So democratic reflection, you can, well, there's a paper here you can read if you want to know more about it, but you can also just go to democraticreflection.cloud if you want to have a look at it. So, as I said, the problem that we are trying to solve is how do we engage citizens to what is normally a quite passive political debate during election campaigns, which is when the political speakers, they are, for example, interviewed by broadcasters or have political debates on television or during live event. So usually this engagement, no matter how important, the engagement process in these phases, it's quite passive engagement. In the past, people would be just sitting in front of the television in their room and watch what politicians said in a very passive way. In the present, what do? We use Twitter or X and different social media to express our, vocal, usually disagreement through web tools and only through our channel. In the future, how are we going to engage with this? Well, probably each of us with a different channel, but really in a very distinctive way. What is happening? So what is the future laying for us? So our research question was, how can we make this very important democratic participatory experience from very passive viewer experience in a much more proactive, reflective, and engaging experience in a very important democratic moment? And I'm starting from the assumption that social media voices are probably not the richest and the most representative, data and way to understand what the audience is feeling around the political election debate. And also to really as a tool for enabling citizens to engage in a much more civic-oriented way in this very important democratic moment. So everything started, everything started with this main question. Sorry, I am getting lost with my slides. Yeah. And democratic reflection was actual initially prototype and then now fully fledged developed technologies for enabling this type of interaction. So what is it? It's a second screen interaction device through which the audience can really have their say and interact with what they are watching on television or on a testimonial video, and to instantly express their emotion in the moment while watching. So compared to other technology, if you want other technologies that we mentioned, really it's a much more immediate emotional reaction technologies to the viewing experience, because indeed you have the possibility to interact in the moment in which you are listening, and therefore you have less time to be in a way reflective like other augmentation technology enable you to do. And then from this very personal emotional interaction, the tool creates a sort of blueprints of your experience, both personal and collective experience, and then generates a different type of analytics and visualization that aim to enhance your understanding of and your perception of your experience, and also the collective perception. So the main democratic reflection experience, user experience, is composed of, let's say, 4 steps. There is a pre-events warming up. So before the live political debate, people are sent a link. They can browse it from their phone or their tablet or their computer. Some initial demographics are collected before they participate, and then the collective watching experience starts. You can imagine that it could happen in a lecture theater, in a cinema, or with people distributed in their couch in their own room. At the end of the live event, then after the audience feedback are collected, there is a phase in which post-events analytics are presented, and then there is a sort of admin area where the collective analytics could be also explored. But how do people express their reaction to the debate? So the main kind of innovation of this method is that audience feedback reaction are collected in form of very intuitive, very semantically charged linguistic statements that are written in lay languages so that everyone can easily read them and select them and click on them like if they were lifting flashcards. And you can see some example of the statement we used in the image. And of course, these are really voluntary, not intrusive. They are there. You can click on each of these statements while watching through your phone, while watching TV, or while watching the panel event. But you can also ignore it. And then at the end of the event, this will enable different sorts of analytics. I just want to show you some example cards we tested in the future to give you a sense of how nuanced and rich could be the things we capture. So these were trust cards that we designed to provide insights on the main motivation for audience trust and distrust. And we could build semantic statements that aim to distinguish between trust in the speaker trust in the debate content, and pre-existing beliefs. So, of course, it's very different if you say someone is talking, a politician, you say, oh, he is being vague and avoiding the question. So clearly in this if an audience select this card is appealing to a distrust on the speaker despite what he is saying. While if you click on something, this is wrong statement, clearly you are objecting to the specific claim that the politician is made, to the content of the policies. At the same time, if you click a card like, I don't believe this, then clearly you really are not challenging the evidence, you are not challenging the speaker, you are really flagging a sort of this general distrust in the debate. So this is just an example of how fine-grained you can have also to capture emotion, for example, or things like question cards designed to provide insight on the audience information needs in order to make this audience experience much more informative, like, oh, people need more information about this. They want to know if it's true. They want to know if I can trust this politician or not, and so on. And there is, of course, a super rich variety of theories, the card statement that we have been testing over the year. We have developed an app and applied it in many contexts, and in particular in the three last general UK elections. So at this point, Lucas, I think I would want to go to the main website. Can I just do that? Yeah?
Yes, please, you can just share your screen here.
So if I share my screen, so
yeah, we can see your screen here.
This is, as I said, DemocraticReflection.cloud, and it gives you a bit of story and link, concept demo of it. And then you have some test drive where you can go and experience different interaction feedback contexts and cards that we have tested. For example, this is coming from the 2007 leaders debates. So this was the sort of the cards screen that you would see in front of you on your tablets or phone while you are watching television. So you can reflect, for example, this politician is speaking, you select your target and says like, okay, he's speaking to me honestly. Now you can keep clicking this card and the card becomes bigger to represent how strong you are feeling about this. For example, if he has given us a wrong statement, or if you feel she's understanding people like me, or what she's saying will really make no difference, or she's offering us a real choice for the next election. So people can go on, and as you click on the cards with the different intensity, you can basically capture your reaction to the live event under these four main dimensions of democratic engagement. So how they are speaking to me, do they think they are being manipulated? Do you think they are being manipulative or condescending? Do you think they are speaking to you in a way that's honest and fair? Can you make sense of what they say? Is what they say relevant to you? And do you think they will make a difference? So we take this 5 dimension, and this is the type of interaction we tested. Another example was what we tested during question time. We had a much smaller number of cards in this case, only 2, no target, because question time was also only 1 speaker, so we didn't need to have a target. While in the case, for example, of the ITV leader debate between Boris Johnson and Corbyn, we did have the 2 leaders, so you had to select the leader, and then click on the cards that you think was better capturing your emotion. We also tested this as a replay interface where is it? With Aegis Trust, an NGO that really wanted to capture feedback to video replays of different key video, in particular, in this case, from the genocide rescuer in Rwanda. And this is what it looks like, the interaction. So when you have a video, you will be seeing the video playing here. And
abakoze jenoside
as you watch the video,
bakashyira mu bikorwa,
if you hear
batanze
these
inyigisho mbi,
things is
inyigisho ya
calling you to,
tumye
for
igihugu cyacu
example,
kigwa mu icuraburindi,
they are saying
inyigisho
something that must have been very different,
abatutsi
very
barenga
difficult. You click on
miliyoni
this card
basiga ubuzima,
and you can see a heartbeat showing the
ibikorwa
feedback
by'indengakamere
of your reaction
jenoside byaba
in the
ari
screen here.
abantu bakomeza
So this is the
umuntu
audience interaction technology. Now I have to go back to my slides. How do I do that?
Yeah, I will re-upload.
But basically,
take a moment.
What's happened at the end of this interactive experience, you are gonna get then, once the event is finished, the analytics, your personal analytics on the screen that gives you basically a summary of your own experience. And then when the slides are up, I will give you an example of some personal analytics and collective analytics that you can get out of this interaction experience, and in a way give you an example of how it can give you better insights also on the events. In a way, the political leaders, how well they were perceived by different type of audience. There are features through which you can, for example, select specific demographics. So if you might want to know how young people reacted, either in a specific time of the debate or toward a specific leader, you could select the leader, select the time, and then you would see statistics on the different interaction according to different either trust, emotion, and other dimension of engagement. Lucas, don't worry. I think if it's too complicated, I think I'm over my time, right? I can't hear you.
Your your time just finished. So yeah.
All right.
It's
I
think it's time.
I think that gives you an idea, and if you want, I mean, in the slides, I can show you more the analytics.
Yeah, we will share the slides later on along with the recording. So I think people, if they're interested, they will have the chance to see what else you have to say there.
Probably, if I can just add a last thing, what is probably interesting would be interesting for people, because it's linked to some of the question we got this morning, is that from our testing of democratic reflection in the 2015, 17, and 19 political election, we found that it had incredibly positive results in terms of changing people perception about politicians, and even affecting the way on how, and changing the way they intended to vote, which was a quite interesting results in terms of the use of these technologies for critical thinking and to really inform political decisions for normal citizens. And also we had really good results in terms of engagement, also from people that are not digitally literate and that were not previously trained. So that's it. I pass
Awesome.
now
Thank you.
to Christian.
Let me remind, let me remind people that they can post their questions through the Q&A, and I will hand it over to Christian, that will show us DispuTool.
Okay. Can you hear me?
Yes.
Yep.
Great. Okay, thanks, Lucas. Thank you, everybody. My name is Christian. I'm currently on a postdoc at the CNRS at Université Côte d'Azur in France. And as part of the group, we are currently studying the adaptation of this DISPUTool that I will show you briefly on argumentative debates, particularly in argumentative debates for deliberative democracy. So a little overview. We are going to talk about the importance of AI as a tool for democracy, as most of this event has been brought it up. We will discuss what is argumentation mining, why is it important to understand the debate process. I'll show you DISPUTool as a use case of AI helping democracy, and I will discuss a little on the further adaptations that we have to use to do our DISPUTool for our particular scenario of deliberative democracy. So as it was discussed in most of this presentation, AI can either be beneficial or detrimental for democracy. There are a lot of famous cases. The one that it always resonates with me is the one of Cambridge Analytica, which is an excellent example of how using data and AI applied wrongly can really do much damage to democratic institutions. Particularly with the search of large language models, we have the challenge of disinformation, with the fake news, with political advertisement, and most of all because tools like ChatGPT are quickly replacing traditional web search engines in a manner that can be detrimental, because the way they explain stuff, they do not give to the user that doesn't know how these things work. It doesn't give the benefit of the doubt. So we must provide AI solutions to fight back this malicious usage of AI, right? Argument mining, it's a research area of natural language processing. It searched around the mid-2010s, and it has been gaining traction. It studies the automatic extraction and identification of argumentative structures from free text that can have any argumentative structure, of course. It's applicable to a large number of areas, for example, medicine, social media, legal documents, among others, and is useful for the automatic analysis of deliberative debates. Things as stance detection, factuality check, and analysis of contradictions in the discourse in deliberative discourse are some of the usage that that argument mining can have. So, what is DISPUTool? DISPUTool is a tool for mining and exploring arguments applied to the US presidential election debates from 1960 to 2020. So it takes the last 60 years of the political debates in the US presidential election. The tool is available through this link that I leave here. It provides the argumentative structure of the debates for each of the presidents, and it is possible to visualize identified components such as claims, premises, and fallacies from the different candidates, and the argumentative structure as relation of attack support between each of the components. The model is also available for analyzing free text given by a user. Of course, as it was developed using these US presidential election debates, it's more or less limited to the structure. It's more or less expecting the structure of the political debates of a political debate, right? So here is a demo of DISPUTool. If you can see it, yes. So it has the different presidential election debates from 1960 to 2020. And for example, you select one example, and then you have in a tabular manner the different basically the different components as premises or claims given by the different presidential candidates. And you have, for each debate, you have another way of visualize both claim and premises from the whole presidential debate in a very visual manner. And you can also analyze the relationships, the structure of attacks and support between the different positions given by each of the candidates. In this case, for example, in the squares are from Ford, and the circles are from Carter, and the arrows indicate the type of relationship they have. For example, here is a claim from Carter attacking another claim from a claim, I think, from Ford attacking another claim from Ford or from Carter. So that's more or less the tool. And of course, there are other visualizations, like, for example, here you have the famous word cloud of what were the most used words in this particular year for these particular candidates. And it also provides here another set of the fallacies in what is called a Sankey diagram, the kind of fallacies used by each of the different candidates and what type of fallacy those were. And finally, the tool provides the model for it's open for usage for analyzing any other free text that, of course, has some form of argumentative structure. Here are some examples. Then you can paste the text there and analyze it. That will take a little. We'll skip. And sorry, wait, let's go back. And finally, you see the results of the analyzed text. In this case, with claims, premises detected, and the structure itself of the text of those components. So, well, as I said, this is a demo. It's available for anyone to start using if you want. And the idea of this tool is to adapt, because this tool is very specific and very domain specific for the usage on data that might doesn't have to be the same, but has to more or less come from the same domain as a US political debate text. So the idea is, as part of the ORBIS project, we are studying how to extrapolate the AI model from DISPUTool to deliberative democracy. The final objective is to analyze the arguments proposed by the cities within the European Union. And it provides many challenges because the thing with the political debates of the US presidential candidate is it's a dataset that is available online, and it can be extracted pretty much without many things like having to deal with anonymization, because of course they are public debates. In this case, for the ORBIS project, we are trying to focus on private citizenships that might not be okay with the idea of their whatever they speak being collected. So we have to deal with anonymous data collection, because all of these models require a large amount of data to properly function. We also have the the challenge of less formal steps. The U.S. presidential debate is a very old practice, and it has a very well structured manner to be presented. And in this case, in the case of ORBIS, we do not rely on that kind of structure. So we have less formal setups and less structured scenario, which can provide a certain set of different challenges that we have to analyze, and we have to see how we can extrapolate and adapt this DISPUTool model to the particular problem that we have within the ORBIS project. And that's it.
That's perfect. Thank you very much, Christian. While I am trying to upload the presentation for the next speaker, let me introduce him. It's going to be Andreas Karapetian, but he's going to talk to us about AI for Gov, which is a self-explained visualization workbench for bias detection. Let me remind everyone that you are invited and encouraged to post your questions to the speakers through the Q&A room. Andreas, the stage is yours.
Great, thank you, Lucas. So hello, everyone. My name is Andreas Karapetian, and I am from University of Piraeus Research Center. And I will demonstrate some of the tools that have been developed within the AI for Gov project. So first of all, let's take a look at the components and use cases that will be explored during this demonstration. First of all, we have the visualization workbench that serves as the project's, let's say, front end and hosts all of the tools that are developed, such as the Bias Detection Toolkit and the adaptive analytics framework and policy-oriented AI and NLP algorithms, which includes a question answering service, a time series analyzer, and predictive analytics. Now let's see how these components are mapped to each of the use cases of the project. So the first one, called the AIUK Top 100 Projects, is provided by an institute in Slovenia specializing in AI, and it utilizes the visualization workbench and the Bias Detection Toolkit. The second one, called the OECD Policy Documents Analysis, also provided by JSI, utilizes the visualization workbench and the question answering service. The third use case, called Parking Tickets Monitoring, is provided by the municipality of Vare Voula Villarmeni in Greece, also known as VVV. And this use case utilizes the visualization workbench, time series analyzer, and the predictive analytics. And the same components are also utilized for the final use case, again by VVV, called Waste Management Pay As You Throw. Now, let's take a quick description of each use case. For the first one, it is an initiative that funds projects to address problems related to SDGs by using artificial intelligence. So the final goal for this will be a checklist for both the reviewers, but also the applicants of the program. But as a first step, and mostly concerning the applicants, we have developed a catalog of projects that aim to mitigate bias in every step of training and designing a machine learning model. For the second one, the OECD documents is a collection of various national AI policies and strategies for many different countries. And here we will showcase the functionality of an extractive question answering and multilingual chatbot that provides information directly from these papers. Sorry, I forgot to mention that for the first use case, the stakeholders are obviously the applicants of this program, which are mainly machine learning models. For the second use case, the stakeholders are policymakers, public authorities, researchers, general public, and probably journalists as well. For the third use case, we predict an area of interest where it is most likely that the specific traffic violation can occur within the premises of the municipality, so that the stakeholders can allocate the resources needed, let's say, for example, municipal police. So here the stakeholders are mainly workers of the public authority or policymakers. And finally, for the waste management use case, this is about a routing optimization of the municipality's garbage trucks. First, we predict the bin fill levels, and then we make a prediction for the optimal path that needs to be followed by the fleet of trucks based on either time or distance. We can minimize either one of these two. And again, here, the stakeholders are mainly the workers in the public authority or policymakers. And finally, let me just address the data that are being used for each different use case. For the first one, data is coming directly from literature overview, and it will be updated as we will give users the option to add new tools and projects to the catalog. For the OECD documents, we have the policies collected by OECD, and they are updated biannually. For the third one, we have historical data by the municipal and Hellenic police forces. And for the last one, we have also historical data regarding bin IDs, timestamps, fill levels, but also the bins themselves are equipped with sensors that are daily updating their fill levels. So I think I can proceed with the live demonstration of these tools. So let me share my screen and we can begin. So you should be seeing my screen. So yeah, let's begin with the first use case, which is the ITHACA Guide Top 100 projects. So for this one, let's pretend that I am an applicant to the program, and I want to develop a machine learning model regarding voice recognition. I want to train this model, but in my attempt to do so, I'm worried that I might introduce bias to the model. So what I do is I decide to use the Bias Detector Toolkit provided by the AIUK project to find out more about bias in AI and explore ways to mitigate it. So I can expand the Bias Detector Toolkit and start with the introduction, which is an introductory page to three concepts. First, we have what is bias, a short description. Then as I scroll, we move to what is AI, which is a short description of the term. And finally, we combine those two in bias in AI, how bias can infiltrate AI and what consequences this might have. Moving on, I can see three examples, real-life examples of bias infiltrating AI in three different sectors, which for each I also have a description, a proposed solution to this problem, and some references in case I want to find more information on each scenario. And finally, I am prompted to explore the bias detector catalog, which, as I mentioned previously, is a list of available projects provided as solutions to all of the different steps, which I will also do. So here I have the available stages where bias is more likely to be introduced. So my problem was on model training, my use case. So I will click on that and I see a list of available projects. Within those projects, I can spot a project called Bias in Automated Speaker Recognition. So this looks interesting. I can unfold this option and I have information about this project regarding its source, its type, a short description, its applicability, which I can see applies to multiple domains, some possible limitations, and of course, references since this is a scientific article. And at the bottom of the list here, I can also see another project called Evaluation of Voice Technologies. This looks also interesting. So I can see that this is a GitHub tool written in the Python programming language. So this could be easily integrated to my code base since, let's say, my model is also written in Python. So this is how collectively the Bias Detector Toolkit helped me as a machine learning engineer and researcher to find solutions on mitigating bias in my use case and preventing it from even happening at the first place. So now let's explore the second use case and let me introduce you to the policy bot. For this scenario, let's pretend that I'm a policymaker that wants to find information on the OECD papers of a specific country. So I will start typing an example here, a question. Let's say, let's ask, what is the national strategy for artificial intelligence? And I will apply this question to, let's say, the country of Italy. So as I send my question, let me provide you with a bit of a behind the scenes what the policy bot does. So the policy bot will provide me with a direct answer. which usually consists of a few words. And this is its best attempt to directly match my question with what it has found within the OECD policy papers. So it will also provide me with some additional text, which serves as a context to my question. This is also derived, again, exactly as is from the policy documents of the specific country. So I can see here my message is being written, my answer, and this is in English, as the policy bot scanned all the Italian, let's say, papers and did the translation so that the message can be provided in English. So on the top here, I can see my direct answer, which says to increase public and private investments in AI and related technologies. And I can also see that my answer is included within the context provided by the double asterisks here. So let's see, what else do we have in this message? National AI strategy aims to achieve some objectives. For example, to strengthen the AI research and innovation ecosystem, support the adoption of AI-based digital technologies, and promote awareness and trust in AI among citizens. So this is useful information for me as a policymaker in order to better understand the context of these papers for each different country and have a more direct access than having to go through each one by one by myself and lose precious time. Now let's proceed with the third use case, which was the traffic violations. So for this, I am a municipality worker that wants to make a prediction on a specific area where a certain violation can happen. So I can choose my time. So let's say I want it to be on March, on a weekend, and let's do nighttime. And here we have a list of many different violations. So for this example, let's select, for example, illegal parking. And I will ignore these two for now and make the prediction. And we can see on the right here, I have a map generated that showcases the area within the municipality premises where this specific violation is more likely to occur in this specific point of time. But let me clear my prediction and go through this step once again. But this time, I will also select these two optional parameters, which are a date from and date to, which provide me with a time range. So for this example, I will select the whole year of 2022. So here I do December 31st. So let's see what will happen now. As I make my prediction, on the top here, I have the exact same map as before, which is my predicted area within the municipality. But on the bottom here, I have, and if I click play here, I have a map showcasing the geospatial evolution in time, where this specific violation, illegal parking in our example, occurred during the whole year of 2022. So this as a whole provides me with a more clear view as a municipality worker on this matter and aids me to make better decisions and perhaps revisit some of the policies that we had for this specific issue. And finally, for our last use case, this is the waste management, where I can generate the prediction for the bins fill levels in the municipality for, let's say, the next 24 hours. And once this is done, I can now select which bin category I'm interested in. Let's say, for example, the organics smart bins. And I can select the variable that I want to minimize. Let's go for distance for this example. And here I have all of the available vehicles at the municipality with their license plates and their capacity in liters. So let's say that our worker in the municipality wants to utilize all of the available vehicles for this prediction. And so if I show the prediction, what I have here again on the right is a map with some points. These points are all of the bins that are allocated to each different vehicle. As you can see, as I scroll here on the bottom of the map, I select the vehicles. And what I immediately notice is that for the last 3 vehicles, there are no allocated bins. This 1 point is the starting point for these vehicles. All of the bins are allocated to the first vehicle. So if I go here on the left on this panel, I also have the 4 vehicles that I chose to utilize. And if I expand upon these vehicles, I can see some information regarding their estimated time that it will take, the distance they will travel, the load, and the fuel cost. And of course, this is the optimal path that it needs to be followed by this vehicle in order to minimize distance and perhaps also save some fuel. So for the rest of the vehicles, I see that nothing needs to happen. And of course, here on the bottom, I have a summary of all of these values as a whole from all 4 vehicles. So from this example, as a worker in the public domain, I can understand that I didn't have to utilize all of the fleet, all of the available vehicles. I can just do one single vehicle, and this helps me make better decisions as well on this domain as well. And so with that, we conclude our demonstration from AI for Gov tools. And Lucas, we can go back to the slides.
Perfect. Thank you so much, Andreas. Very interesting. Again, I welcome everyone to post their questions in the Q&A. I actually posted some for you and for Christian. And lastly, now we have the ORBIS presentation, which is going to be presented by Nikos Alibertis and Ioannis Livieris. So, Nikos and Ioannis, the stage is yours.
Yeah, thank you so much. Hello, everyone. It's my pleasure to be here with you today. As Lucas said, I'm Nikos Alibertis, and I'm the research engineer of NobelCore. Today, let us present to you the idea and the progress regarding the European project named ORBIS, a project, as we mentioned before, that shapes and supports new democratic models that are developed through deliberative democracy processes. Here we can see the challenges that have to be addressed. These challenges are about facilitating a meaningful collaboration between citizens and policymakers, about exploring innovative approaches for citizens to fulfill their social responsibility by actively participating in democratic issues, about establishing faith and transparency in the democratic policymaking process to enhance public confidence, about promoting increased participation and civil engagement through the implementation of digital democracy solutions, and about developing the scalable digital democracy models and solutions applicable at various levels, as you can see here. And these were the challenges. Now, we try to sketch our idea and our solution regarding the nice concept of deliberative democracy. But what's the output of this deliberation? What this process provides to us? Usually we have transcripts, for example, a bunch of documents. But some documents can provide us much information without specific structure. Therefore, the question is how we can explore this deliberation. Can we extract some positions over issues, some interesting arguments, etc.? Here, it comes ORBIS. It tries to convert these transcripts, this unstructured information, to semantically rich machine-interpretable discourses. And now we need to pay attention to these three major issues: how to get the feedback and analyze it in a meaningful way, how to aggregate the feedback, for example, clusters with similar opinions or similar concepts, etc., and how to visualize this deliberation to engage people to make them aware of what's going on. We will show you some examples of some platforms that can provide us information that we can analyze through this process. One interesting platform here is one that's called Have Your Say. In general, there are various discussions on this platform, and here is an instance of a deliberation about hazardous chemicals. The key point here that I want to emphasize is that these platforms have no ML or NLP processes to analyze people's opinion and feedback. Everything is unstructured, as I mentioned before. And here, as you can see, there are 2,668 feedbacks. Feedbacks means comments or pieces of comments in general text. And here is what we do. We try to cluster these opinions collected from this platform. We can see the output, the visualization part of these two groups that prevail here. As we can see here, using the AI algorithms, we get a summary of this cluster, of this bunch of opinions that I said, and we produce a title for this cluster, and we extract also the top keywords. And similarly, we apply the same for the second cluster. All of these results came from this feedback that I mentioned before. And this it was the first example. Now, the second example is from another platform called Polis, a web platform where citizens can express their opinion on a specific topic, and they can answer if they agree or disagree, or even they have a neutral position. This example is regarding Brexit. The issue that is under investigation in this case is the following: can there be consensus? Can there be consensus on Brexit? And here we applied another bunch of algorithms related to sentiment analysis to see who is in favor or against, skeptical, etc. Now we want to present to you briefly what we have done so far. The first approaches are first prototypes. So I would like to share my screen to navigate into the software, and I will skip these slides. Just give me a second to share my screen. Okay, I think that. Can you see my screen now?
Yeah, we can see. All good.
Thank you. So there is much information regarding the issue. We can see the number of positions here, the number of arguments, the users, the top keywords here, the influential users that have got many responses to what they have said until now. In addition, we produce timelines. These are the 3 positions, for example, that we have extracted. And we can see how many arguments per week correspond to each position, for example, to this timeline, or respective timeline with the clusters, meaning the arguments. And now this is our attempt to visualize the discourse. Give me a second. Okay, perfect. And now we will show you the graph, this graph that corresponds to this specific topic that I mentioned before, with the title, Can There Be Consensus on Brexit? And these are the 3 main positions that we have extracted from the opinion mining of the sentiment analysis process. And this is with a light blue. I'm rather skeptical on this issue. I doubt we can agree on it, and consensus is highly feasible. The children nodes that we can see here are the clusters of the arguments expressed so far. Each cluster can provide, again, the summary and the title of the group of arguments that corresponds to the arguments of the cluster. And for example, when we open a cluster, let's see here. Okay, we can see the individual arguments. The color of these nodes, of the child nodes, child node corresponds to a supportive argument if we have blue nodes, while the orange one is an argument against the position. So just stop my share screen. Lucas, could you bring me back the slides?
Yes, but give me 1 second for that. It will take a couple of seconds. Sorry.
Thank you, thank you.
Oh, yeah, you should be able to be back now. Yes.
Yep, sure. Okay, so I present the dashboard here is okay. So okay, this that we presented to you is our effort to visualize, to give an idea on what's going on in this discussion. Now, in this slide, we mentioned some approaches that we followed for the respective task, for clustering, for summarization, for example. And let's say for the summarization, for example, we have follow three approaches. An extractive approach is the one that selects directly sentences from the original text, while the abstractive approach creates a summary to understand the source content, etc. And here to sum up, we would like to conclude that our goal is to build a partnership between human and machines to build an advanced deliberation that solves all the challenges that we mentioned in the first slides at the beginning, such as to enhance the creativity and collaborative strengths of humans and to restore the trust of citizens in democracy. Thank you so much for your attention. More information may be found in the corresponding website of ORBIS project. Thank you. Thank you.
Thank you, Nikos. Thank you so much. And I think by this will be the last presentation. And with that, we have reached the end of the presentations. And what we're gonna do now is that I invite everyone to follow this Mending Interest survey link that is there. I also have pasted it on the chat. And you can also do it by just going to menu.com and use the code there, or just follow the QR code. And what is the survey is you're just going to offer some feedback on the 5 tools presented. So you're just going to have to answer a few questions of that. That will really help us, all the presenters, to see how relevant their tools are and improve them and make it better. In the meantime, we have some questions in the Q&A. Please, by any means, if you have more questions, post them here so we can start answering some questions. So I can see a question asked by Maria that she's asking me. Thanks for the demo. Are there rules for interacting on the platform? How can we ensure that the platform will not be flooded by trolls? Will it be moderated? So thanks for the question. The thing that we make a great assumption in our so far development of BCause, and is that we are dealing with good faith actors. But we, at the same time, we acknowledge that this is not always the case in modern internet. Yeah. So moderation itself is the way that you can implement moderation is sometimes is problematic. So through our design, this design that we are asking people kind of prompt them to answer into a given argument and not answer to the person expressing the idea, we believe on its own by design is a good factor to to mitigate this problem of trolls or malicious users. So in our future developments, I think we're gonna implement some sort of moderation, but we were only gonna keep it for the extreme cases, you know, the cases that, of course, you have some very malicious user that is just there to troll and flame the discussion and nothing more. But in general, I think we would very be hesitating to implement some sort of automated AI moderation in that tool. Instead, we want to promote through the design of promoting the argumentative discussion to solve this issue. I hope this answered your question. Right. We have a question.
Yeah, thank you.
Yeah, thanks. We have a question for Christian. So, Christian, about DisputeTool, how different and in what way will be the argumentation model that is used there, which is crafted for presidential elections?
Yeah.
How, when you want to adapt it for normal deliberative democracy things, as you said in your last slide, for example, when a local council wants to make a decision about a road, about some sort of transport,
Yeah.
How what sort of adjustments or you need to make to adapt it for this use case?
The short answer is right now I'm not really 100% certain, mostly because it has been difficult because of the issue of anonymization to come across data that has the structure that one would expect. As I say, most of these models are very based on linguistic cues to determine the structure of a deliberation of an argument. So basically, there are certain guidelines when you are annotating a data set that you build around these linguistic cues. For example, very specific words that are used in very specific manner are usually said, okay, blah, 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 therefore X. So it's after that, therefore, it's usually the X comes as a claim. And whatever is before is usually the set of premises that support that claim. So as you have this kind of scenarios, and this is very classical in the US political debate center, that is, there's nothing to say that this will be as well the same scenario for the case of a local council. That's everyone will talk in that very structured manner. So the model in itself learns these cues as well, because that's how most of these transformer models work. They don't really think. What they learn is how is everything structured, and that's what they use in itself. So if there's like very different ways of communication between the local council and the US presidential debate, the model will perform poorly. What you have to do is to get feedback from the model and try to make it fine-tune it better to that kind particular of data that you will have to deal with. So that's basically the idea of these models, is mostly to understand the structure automatically. That's the mining part. So it can give the structure, and then there are other models that are useful, for example, for detecting once the structure is detecting inconsistencies in the structure or things like that. And that can be used as well to build a model for decision makers. The decision should never be in charge of the model. That's a very bad idea because it's an AI, but it could help decision makers seeing, okay, whatever they are saying here, yeah, it makes sense, or no, it doesn't make sense, or maybe there's contradiction within whatever they are saying. That's the idea of the model. But the model, as it is defined, as the task is defined, it's very much reliant on linguistic cues. So if there are very different ways of communication, the model will most likely perform very poorly. Sorry.
Yeah. Thanks for this. I also have one question for Andreas about the AI for Gov. So it was very impressive, the use cases that you have presented, and very nicely done, if I may say. So my question to you is that if I understood correctly, your bias toolkit is able to provide is able to highlight some sort of common mistakes, common pitfalls that people do. But will you be able to contextualize that to the specific use case? So for the example of training a model, will you be able to say, you know, you are doing it in this way, and this may lead you into creating bias in that way. You should instead do this. Will you be able to generate this sort of helping guidelines for people, or is just to detect possible biases?
Thank you, Lucas. Yeah, currently the scope was for the datasets and generally the data that are being processed in the context of the project. So for this use case, that was showcased the bias detector catalog that is being fed with all of this information. But yes, we are in a phase that we develop some, let's say, complementary tools in the bias detector toolkit that will be applied on top of any new ingested data that will come from the users and the researchers in order to, let's say, measure bias in data and data sets, and provide, as you said, some suggestions for the researcher, and provide information also how to proceed, let's say, with some mitigation actions in order to do so. So yeah, this is currently being developed and will be available in the future as a toolkit, let's say, a complete toolkit.
Yeah, awesome. I don't have any much other questions. Maybe if any of you or any of the presenters has any other question to another presenter, please just unmute your microphone and address it to the speaker. Give it a few more seconds to make your mind. Okay, if we don't have any more questions.
Can I ask a question
yes,
to
yes.
the AI for Gov guy? Should I remember
Andreas.
your name?
Andreas is for you.
Yeah, Andreas, sorry, I didn't remember. I really love the way you have also presented your use cases in a combined way and interface. I like that a lot. I had a question though. Is in your plan to deliver some of this functionality as a standalone tool, or they will be just bespoke example for the AI for Gov project?
Well, the plan is to be as tools integrated within the platform of the project. So probably not as specific, let's say, separate tools, but we will also see. But yeah, the plan is to be all within the visualization workbench, the platform of the project, as use cases.
So if I was another municipality like that, I wanted to use your tool, I wouldn't be able to do that, would I? Like, for example, the one of waste management or...
Yeah, well, this could be continued after the project, perhaps, as to be a separate tool that can be integrated within the all of the municipalities' systems and so on. But for now, it is, let's say, vision to be in a whole platform, just to showcase the different use cases of the project.
It would be very useful if they were separate. Physically,
Yeah,
I'm suggesting you to go that way because I can. Well, I suppose the catalog can be used already as a standalone
exactly.
tool, but the other two, would be very useful. Okay, thank you very much.
Thank you, Anna.
Right. Any other questions by anyone? I'll have a last look in the chat. I'll have a last look in the Q&A. And I think we don't have any more questions. So as a very last thing that I will ask everyone to do is to follow this link for the feedback form. So the Alan Turing Institute is asking from everyone that attends an event in the AI Fringe to fill out this diversity monitoring and feedback form for the event. So this will be a feedback for the event as a whole. You might need some time to finish that, so I will make sure that I will email it to you after we finish this event. But if you wish to start already to do that, please do. I think it's gonna take you like 1 or 2 minutes to do so. For any other questions that you have, any other inquiries on the tools, on the presenters, on the topics that we discussed today, I invite you to send us an email to the email that I share now on the screen, AI-big-data-and-democracy-taskforce. pretty much AI, Big Data, and Democracy Task Force, split by dashes at googlegroups.com. And it was a great event. Thank you very much, all of you that have attended. You stayed up until now. It was 4 hours, full of interesting, I hope intriguing talks by everyone. So thank you very much for joining us. And thanks to the speakers, first of all, and thanks for all the attendees and participants.
And thanks for the great organization, Lucas.
Yeah,
Yeah,
if you
thank you,
if you have missed something, I will also share the recording afterwards. So you will be able to replay it and watch it as many times as you wish. Thank you all and have a great afternoon. Thank you.
Thank you. Bye.
Bye.
Thanks.
Thank you.